To the organizers and participants of the 2023 EdTech International Conference in Education and Learning Technology, good day to all of you. I am very honored to present to you my research with the title Revolutionizing the Online Arduino Programming Education Using Tinkercad During the COVID-19 Pandemic. I am Blancaflor Arada, an assistant professor from the University of the Philippines Open University located at Los Banos, Laguna, Philippines. So to start my presentation, we have the Arduino. It is an open source electronics platform based on easy to use hardware and software. Because of its simple and accessible user experience, Arduino has been used in thousands of different projects and applications. The Arduino IDE, or the Integrated Development Environment, is easy to use for beginners, yet flexible enough for advanced users. It is cross-platform as it runs on Mac, Windows, and Linux. And then we have the Arduino microcontroller board. Because of its cost effectiveness, it is widely used in prototyping, robotics, and Internet of Things or IoT projects. However, learning Arduino programming can be challenging, especially for beginners who lack the necessary hardware or have limited access to physical components, such as shown in the slide. So this is the Arduino Uno R3, one of the most popular Arduino microcontroller variant. So next is we have the COVID-19 pandemic. This has forced many educational institutions to shift their teaching and learning methods from in-person to online and distance learning. In particular, college education, not only in the Philippines, but also worldwide, has been greatly impacted as hands-on laboratory activities such as programming and circuit building are more difficult to facilitate remotely. So next, the solution is Tinkercad. It is a free web application simulation platform off the desk. Has emerged as a potential solution for teaching Arduino programming remotely. So this study aims to explore the effectiveness of online Arduino programming education using Tinkercad during the COVID-19 pandemic to identify the learning outcomes, challenges, and opportunities of this approach. So the methodology used here is a post-evaluation survey based on the system usability scale. So to investigate the usability of online Arduino programming education using Tinkercad, the researcher conducted a post-evaluation survey based on the system usability scale or the SUS questions using Google Forms. This is to assess the effectiveness and efficiency of Tinkercad as an Arduino programming learning platform and the satisfaction of students while using the web application. So we have 10 SUS questions, and then the participants are 42 first-year computer technology students, which is the sample size of the student population taking up the programming of Arduino classes in a state university. A 5-point Likert scale is used. Number 1 is for strongly agree. Number 2 is agree. Number 3 is neutral. Number 4 is disagree. And number 5 is strongly disagree. So for the first SUS question, 74% agreed that they would like to use the Tinkercad web application frequently. At the time that the survey was conducted, the usage of Tinkercad is required in their Arduino programming online class. Second, 37% of the participants generally agreed that they find the Tinkercad web application unnecessarily complex. Next is we have third, 67% of the participants agreed that the Tinkercad web application was easy to use. The web application can be used by the students well to understand the Arduino programming using its simulation. And the next is we have fourth, though the Tinkercad web application is perceived as easy to use by 67% of the student population and has an intuitive interface, 55% of the participants generally agreed that they would still need the support of a technical person to be able to use the application. There was still a need for an expert or teacher intervention for students to fully understand Arduino programming by using Tinkercad. And then fifth, 74% of the participants generally agreed that they find the various functions of the Tinkercad web application were well integrated. As evidence of the Tinkercad web user interface, it is complete with the Integrated Development Environment or the IDE for coding the Arduino sketch, the electronic components inventory needed for setting up the microcontroller, and simulation to check the correctness of the Arduino sketch and the electronic components in the Arduino board. So to continue, we have the sixth SUS question. 29% of the participants generally agreed that they thought the Tinkercad web application has too many inconsistencies. And then for the seventh, 64% of the participants agreed that they would imagine that most people would learn to use the Tinkercad web application very quickly. And then for the eighth SUS question, 20% of the participants generally agree that the Tinkercad web application was very cumbersome to use. And then for the ninth, 57% of the participants generally agreed that they felt very confident using the Tinkercad web application. And then last but not the least, the 10th SUS question, 57% of the participants generally agreed that they needed to learn a lot of things before they could get going with the application. Just like learning any programming language, it is imperative to learn about concepts related to Arduino programming and electronic components. So after getting the results, we have to calculate the SUS score. So first, sum the score contributions from each statement per participants. Each item score contribution will range from 4 to 0. For statements 1, 3, 5, 7, and 9, the score contribution is 5 minus the scale position. For items 2, 4, 6, 8, and 10, the contribution is scale position minus 1. Next is multiply the sum of the scores by 2.5 to obtain the overall value of SUS. And then last but not the least, get the SUS average from the participants' score. And then based on a research, an SUS score above 68 percentile rank would be considered above average, and anything below 68 is below average. So the result of the SUS score is 58 percentile rank of the study, and unfortunately, it is below average. So the question now is why? What are the reasons for the low SUS? First, we have the pandemic has negatively affected the mental health of students, as we have read in many research studies. And then second, Philippines' internet infrastructure. So the country's internet infrastructure unfortunately lags among those of contemporary developing countries in Asia, particularly in terms of internet connectivity. And then third, the results show that classroom learning was more effective than online learning. So the average grade of the participants, which is 3.3, is lower than those of the students who have experienced in-person Arduino programming classes of the previous year, which is the average grade is 2.4. They had hands-on activities with the Arduino board and electronic components, which reinforced the learning outcomes of the course. So for the conclusion, overall, the findings suggest that online Arduino programming education using Tinkercad has the potential to be effective and efficient and provide satisfaction for student learning outcomes during the COVID-19 pandemic. However, challenges and limitations must be addressed to ensure the effectiveness of this approach. So thank you very much for listening, and thank you and good day.